கரத்தனை ஆனை முகத்தனை ஐந்து கரத்தனை ஆனை முகத்தனை இந்தில் இளம் பிறை பாலும் ஏற்றனை இந்தில் இளம் பிறை பாலும் ஏற்றனை நந்தி மகந்தனை நந்தி மகந்தனை ஞான கொழுந்தினை உன்னில் வைத்து அடி போற்றுகின்றேனே.
Good morning, all my friends. It's a wonderful Sunday. It's really giving me a great pleasure to spend this wonderful Sunday with you all. It's really an honor to me. I feel I'm very happy, and it's an honor to me to deliver a guest lecture in the forum which consists of two large, very reputed organizations. One is Kadai Chennai, and the other one is very popular Indian Building Congress. I appreciate and I'm very happy that Pradeep Mittalji has come to participate in this meeting, and from my bottom of my heart, I would like to thank both Kadai and IBC and all my friends and also the participants for having come to make this webinar a gracious one. I will go for the PowerPoint presentation now. Just I will share my screen. I think you are able to see my screen, I think, sir.
Yes, sir.
Yeah. Structural assessment in 60 minutes. It's a term given not by me, by Mr. Jayakumar and Arul as a glamorous title, but it's not so. All will know it's very difficult to make a structural assessment in 60 minutes. However, close to that, I will create a confidence at the end of this webinar. You can make a structural assessment without any reluctance and hesitation more easily. So that much assurance I can give. Whenever I see these types of webinars are going on, I understand the upskilling is the key quality of a successful engineer. I will narrate a story and get into my technical presentation. There was a poor woodcutter searching for a job. Poor woodcutter. After roaming here and there for so many days only, he was able to get a job under a timber merchant. Under a timber merchant, he was assigned the job of cutting down huge wooden blocks into small pieces. On the very first day, he was able to produce about 100 pieces. Second day, it has reduced to 80. Third day, it became 60, 40. It was go on reducing. This poor woodcutter himself felt very sad and went in front of the timber merchant and confessed to himself, boss, my day by day, my output is getting reduced, but I don't know the reason, boss. I feel very sorry for that. The timber merchant asked him, are you putting the same effort? Are you putting the same effort which you put on the very first day when you joined the job here? He replied politely, yes, boss. You only helped me when I was in hunger. I want to be very loyal to you also. So I was go on cutting down the wooden blocks into pieces without taking rest, without wasting a single minute. Then the timber merchant asked him, have you ever sharpened your axe in between the routine works of cutting down the wooden blocks, have you ever sharpened your iron axe? He replied politely, Boss, I didn't want to waste my time in sharpening my axe and all. I was going on doing the job of cutting down wooden blocks. With a smile, the timber merchant advised him, unless otherwise you sharpen your axe in between the routine works of cutting down wooden blocks, you will not get good outcome. Similarly, we people, whether site civil engineers or office structural engineers or professors or lecturers or field people, we have day-to-day activity regularly related with our works, engineering works. We never have time or not able to spare our valuable time to upskilling or updating our knowledge. So these types of webinars helps them to update their knowledge to become a successful engineer. At this point, I would like to thank both the organizers, IBC as well as Kadai Chennai, for making this arrangement to spread the experience of me, which I have in structural design field. Thank you very much. So I will go to the technical presentations. So when I was a child, when we were children, we walked through these bridges with a fun. We enjoyed it a lot. This was the fun for us. But after becoming a civil engineer, we were flooded with formula, method of sections, method of joints, everything. And now we started not only the bridges, all civil engineering structures because of formula. But that should not be the way of learning. You must have a passion and love towards our work. Then you will become a successful engineer. What we are taught as a fundamental quality for a civil structural engineer is Laplace transform, Fourier series, double and triple integration, sorts, blah, blah, so many things we were taught. But just forget about all those things, then you can become a very, very good structural engineer. What you should learn? You should have common sense, that's all. Anything, any engineering is nothing but a common sense. You can become a successful civil engineer or structural engineer if you have a good common sense. For example, when you see it's a section of a footing and column rods going inside. Its analogy is a chair without ties. Vertical legs are there, no ties, it will be like this. So it will split and spread away. Whereas just by putting some stirrups like this, ties, I mean lateral ties in the rods, it will not spread, similar to this. Such an approach, such a feel you have in civil engineering or structural engineering, then with a common sense, you can make a great success in your career. But there is always a stage, converting a fresh engineer or beginner into an experienced one is a toughest job. Because fresh engineer need experience, but job providers need an experienced person. So there is a little gap. So when you join a job, you can become a successful civil engineer just learning not only from books, but also from practicing senior engineers, whether directly or indirectly by attending these types of webinars or reading some technical books. When I was young, in late 90s, 98 and 99, I was assigned the job of analyzing the stability of this huge statue, which is called as Thiruvalluvar statue, located at Kanyakumari in Tamil Nadu. Its height is about 133 feet. Such a huge tall structure proposed on coastal area. It is made up of pure stones only. This is the Thiruvalluvar statue. Tamil people knows the Thiruvalluvar statue will be like this. The portrait of Thiruvalluvar, traditionally the bun, the hair arrangements will be vertical, like an inverted cone. This is the actual portrait of Thiruvalluvar statue. When I was given the drawing, at the time computer was not so popular, not handy. So I was given a sketch by a Stabadi, a skilled mason Stabadi. He has given me the sketch, hand sketch, and I embossed it or placed it on a graph sheet, big graph sheet, and counting the area at all stages, starting at foot, leg, hip, neck, and I at last came to this head also. Then the bun, the vertical portion. The formula popularly we use to find out the tension that is created in the masonry structure. We must avoid tension in the masonry structures. The formula, the popular formula is stress is equal to P by A minus M by Z. This P by A is our favorable stress that is due to weight of the structure. But this M by Z is the overturning stress or our unfavorable stress. Unfavorable stress. When I checked the stress at the hip level or neck level or foot level, this factor was high because the load, P is load, self-height was higher at bottom. When I go at top, further top, this first term became very, very small. Whereas because of this high wind force, this term, overturning term became, because of this high wind load, became so large. And this area and the section modulus is the property of cross section of this bun. It became so small, so I got tension because it became so big, it became so small when I go up. As a result, I was go on increasing this sectional properties, which we call it as modulus. As a result, no, I was doing it for 1 week. As a result, the width of this bun hair has become wider than the chest of this statue. It became wider than the statue. That's what the bookish knowledge I had. I was go on doing this calculation only, formula. Then my senior has come and laughing at me, he said, even if you do it for 1 year, it will not be solved. You are sticking on to the formula, bookish knowledge. You just change the profile of the structure itself. Whenever you get stuck up, a routine work of doing calculation and all will not do. He asked me to change the profile of this. That's how this has come. So I have changed the hairstyle like this by increasing the section modulus at that level. So I only spoiled the Tiruvallur statue at Kanyakumari by providing this bun horizontally, not vertically. Of course, I learned this from my experience with senior engineer. So to become a successful civil engineer, you must open your eyes to hear the senior engineers in future. Now I go to the subject. I have divided this into 2 parts. Part 1 is thumb rules. Very easy thumb rules. The next one is structural failures, 1 or 2 case studies also. When I say thumb rules, I will show you how to calculate slab thickness in few seconds on just looking at the building, and how to assess the size of beams, observing the span of the beam and all. This comes under thumb rule. Once you just understand this thumb rule by paying little attention, when I show the features of these failed buildings, you yourself will be able to tell what happened and what caused the failure of this building. So please concentrate on thumb rules first, then we will go to the structural failure case studies next. It's a very simple, our learning a structural design is learning only 4 things: slabs, beams, columns, footings. Slabs, beams, columns and foundation will make the entire structure, and learning these things, these 4 things, we call it as structural engineering. Normally slabs are the structure, carry the loads, but architects and builders and developers or the users want only the slab. They want to take rest in the slab. They don't want beams and columns or footings. But we only, civil engineers, have to transfer this slab load to the beams, from the beams to the columns, from the column it is going to the soil through the footings. Though it looks childish to say loads are transferred from slab to beam, beam to column, column to footings, the loads, brick wall loads will go to the beams, brick wall loads will go to the beams, then to the columns, then to the footings. If that fellow who was in charge of that building which failed in 2014 in Chennai, if that fellow had the concept that wall load has to go to the column through the beam, he could have avoided the failure of the building, or he could have cautioned the concerned persons. So the understanding is the load must go from slab to beam, beam to column, column to foundation. Your brother is taking you for beginners, I tell, to buy an apartment. He is asking whether the slab thickness provided are under construction, whether the slab thickness they are doing is okay or not. Then many things will flow to our mind. L by 26, L by 32, modification factors, blah, blah, curve, everything will come and nothing will come out of our mouth. Our brother will be wondering, you are in the final year of civil engineering, but you do not able to assess or appraise the thickness of slab. So there is a thumb rule which a group of structural engineers develop themselves for their own, they customize and follow it. What we follow for quick appraisal will be like this. For slab, suppose if the slab size is span of the slab, a span of the hall, span of the room, short span is 5 meter. Then you just multiply by a coefficient 3. That will give 15 centimeter, 150 mm. That will be the slab thickness. I'm more on the conservative side, safer side. Suppose if the slab short span of the room is a 6 meter, you just multiply 6 into 3, that will give 18 centimeter, 180 mm or 7 inch will be the slab thickness. So like this, if it is a 4 meter, 4 into 3 will give 12 centimeter. This is how just you multiply by 3 and you can appraise or assess whether the provided slab thickness is adequate or not. And of course, I have provided a table with a little more accuracy for varying span up to 3.5 to 4 and all. But you can remember always by heart it. But it won't hold good for cantilever slab. There are two vulnerable structures in our buildings. One is the cantilever, the other one is floating columns, with which we must be very careful. But the thickness to be provided will be span by 10. Suppose you are going to provide 1.5 meter span. When I say span, it is the projecting length, like a sunshade. You can assume a sunshade projection. The projection is normally 600 mm or 0.6 for sunset. If it is projecting a balcony, is 1.5 meter. Just multiply by, divide by 10. Divide by 10, you will get 150 mm. You will get 150 mm. 1.5 means 1500 by 10 will give 150 mm. So these are the two techniques I used to follow. Even students know, those who are going to do a rigorous analysis of Stanford or ETAPS, they have to assume slab thickness by themselves only. No software is here to tell us the slab thickness, beam sizes, and also we have to assume something. So for that assumption, at least before doing the detailed analysis, you can make use of it. When I come to the appraisal of beam, we calculate the beam size. This is also very simple. You just assume some general grade of concrete, but the span is 6 meter. Span is 6 meter. Just I have to multiply by a factor or coefficient from 7 to 8. That means the 6 meter the span, you multiply by coefficient 7 or multiply by 8, and the depth will be 42 or 48. The depth will be somewhere in between this. This is how I used to calculate when I go to assess the stability of the building. Just I won't use the calculator also. Just I will see 6 meter is there. In mind I will say 6 into 7, 42, 6 into 8, 48. So in between them a round figure will be 45. So that may be the optimum size, and I will see. Or you can say 7.5. So it varies from 7 to 8 for a good design. So I will adapt a depth of 45 centimeter or 450 mm for 6 meter span. The thumb rule is just multiply by 7 or 8. And it can be, width can be either 300. What is, when I say depth of the beam, 450, it includes the slab thickness also. slab thickness will be 150 and 300 will be rib projecting portion down, which is shown exposed outside. 300 plus 150 will make 450. When I say 450, whenever an engineer says depth of the beam, it includes the slab thickness also. So either you can go for 300 or 230 depending upon the span, and for residential building normally we go for 230 to hide the beam inside the wall for better appearance, and in the office it is not necessary, and also the span is more. To place the rods, more number of rods, we may opt for 300. So either you can give by 300 by 450 or 230 450, but I will conclude like this: multiply the span by 7 or 8. So I will repeat, for the slab just you multiply by 3, for beam you just multiply by 7.5. You can just, you need of going calculation and all. Column size. Is there any rule to say for 1-story building this will be the column size? Because it's 3 meter. If it is 6 meter, you multiply by a coefficient and size will be like this. It cannot be categorized like that, because beams and slabs are flexural members. Beams and slabs are flexural members. They fail by bending. WL square by 8, WL square by 10, L square will come. The failure will be moment, L square. So the dominating parameter will be the span of the beam or span of the slab. That's why I was able to arrive a coefficient based upon the span. But here the column will fail because of predominantly axial load. Compressive load from slab, beams and all will come to the column. The controlling parameter majority is the axial load. Of course, bending moment will be that. So I cannot say this much size for this height and all. So what I have to do, I have to do in 2 steps. One thing is I have to calculate load on column on one hand. On the other hand, I have to choose a particular section which will be capable of carrying this load. So 2 steps: load on column calculation, and the other thing, choosing a particular section to suit with this load on column. In the design offices, what we do, we will calculate the load from slab, load from wall, load from beams, self-weight of column, everything. It takes much time. It needs a lot of calculations. Then only we will calculate the weight on the column, load on the column. For that, I need to assume slab thickness. I would assume beam sizes. I would find the self-weight of beam, self-weight of wall, etc., etc. Then only I can arrive at the column load. But normally, we all know, if my neighbor asked me, I am going to build a house in Chennai at Besanagar, how much will be the cost of the building? If he asks, then immediately I will ask him, what is the square feet of the building you are going to build? He will say 1,000 square feet. Then just I will multiply the 1,000 by a coefficient, the rate, unit cost, say 3,000. Then I will say immediately 1,000 square feet into 3,000 per square feet will be the rough cost. So 30 lakhs you have to spare that. You have to make a fund for 30 lakhs I can tell. Similarly, just by seeing the plan, is there any unit load that comes on the column per square meter? Then that will be easier for us to calculate the load on the column in a single step. Yes, there are coefficients like this. We have residential building vertically, and the other column will be office building. Residential building, office building. For interior columns, that coefficient will be 12. You can assume 12. For edge columns, you can assume 17. Then corner column, you can assume 22. 12, 17, 22. This is for residential building. When I say interior column, I mean these 2 columns in the figure here. Interior columns. When I case corner column, 1, 2, 3, 4 corner columns, 22. When I say edge columns, it will be other than corner columns in the boundary I call it as edge column. 12, 17, 22. Based on our experience, it includes all the loads. all the loads per square meter, wall load, slab load, this beam load, column cell, everything includes per square meter load in kilonewton per square meter, 12, 17, 22. And for office building, normally live load will be little bit, 2 will be more. For residential building, live load is 2. For office building, it will be 4. So I will add 2, so 12 became 14, 17 became 19, 22 became 24. But I cannot remember these 12, 17, 22, 14, 19, it's all numbers. How I keep it in mind is 15, 20, 25. It's easy to remember. 15, 20, 25. Like this I remember for interior edge corner. When I say smaller load on interior columns, medium load on edge columns, and more on corners columns, somebody will wonder, corner columns, this corner columns, area will be more, but why you assume the area will be less, contributing area will be less, why you are assuming? At the end you will understand this. Now I will go to this interior column, how you will work out this column. Say this is a 3-bay building, 3-bay, in plan it is like this, upstairs you can see elevation, 3-story building, you take this. It's a child's play. It's a 3.7, 3.7. So this influence area will be 3.7 and this is 6 meter. 6 meter. I'm very poor in drawing, that's why 6 appears to be same as 3.7. So, but still I am called as a good structural engineer. 6 meter is this one, 6 meter this one. So 6 into 3.7 will give this area, that's all. So 3.7 into 6 by 6 will give 22 meters square. 22 meters square. This is the influencing area. Slab load, wall load, beam load, everything in this area will come to this. That area I have calculated. That is 22 meters square. Being an interior column, just I multiplied 8 by a coefficient 12. 22 into 12. You will get 264 is the kilometer. The total load on column will be 3 times. 3 stories are there. So 3 into 264. You will get 792 or 820 Newton. So you just remember this, how to work out this influencing area. You get the load on the column. So this is the coefficient I mentioned for interior column 12. If it is a edge column, I will multiply the respective area by 17 and the pro rata area of the corner column by 22. Then I will go to the table like this. A little attention is needed. We will not be using this table, don't get scared. I will explain what is in the table and then I will switch out to an easy technique. We have whenever we say column, the column load is shared substantially by concrete and substantially by rods also, reinforcement. So if you provide more reinforcement in the same column size, you will get more loading capacity. So load carrying capacity of column is decided by not only the size but also the percentage of reinforcement, amount of reinforcement provided in the column. So this table has size of the column in the 2 vertical rows, vertical columns. We have 230 by 230, 230 by 300, 230, 450. And here we have percentage of reinforcement. It starts from 1, 1.1, 1.2, like this, goes on 2.73 or something like this. So if I want to have a column to carry 800 kilonewton, I will go here and will select 230 by 450, like this, and I will find 794 and 830. So my load on column which worked out is 800. So I will choose a column 230 by 450 with a reinforcement of 1.4%. 1.4. This is how I can choose. It's a usual method only. But I will tell you a secret behind it. Without using the table also, you can somehow assume or assess the column size. You see this here, I have enlarged the previous table and produced a portion of it. 230 by 230, percentage of reinforcement, only 2.6 I have chosen, and load carrying capacity is like this. So if you have breadth as 300 and also depth as 300 for illustration, 30 centimeter and 30 centimeter. You just don't multiply 300 by 300, you multiply 30 by 30, that will be 900. This is the load carrying capacity. So, a 30 centimeter by 30 centimeter column, if you provide 2.6 reinforcement for M20 grade, of course, you will get 900 kilonewton. This is one way of rough method of assessing the column size. For example, if you come to this 300 by 400, 30 into 40 will give 1200. 300 into 600, 1800, 2.6 reinforcement. So just you remember, load carrying capacity of column is cross section area. Of course, if you provide 2.6%. You just remember this, because when I go to the case study failure of column, you yourself will be able to tell what should have been the column size there. So load carrying capacity is nothing but cross section of the column with particular percentage of reinforcement. So you can put this 2.7 and also you can find out, if you work out the 2.6 by 100 size and all, you can find out the reinforcement also very easily. But the IS code says you can conveniently go up to 4% of steel in the columns. If there is no congestion, you can go up 6% also. But what is the economical column? Based on our experience is a column with the percentage of steel varying from 1 to 2% will be the economical. In India, the site made concrete is cheaper than the factory made steel reinforcement. So it is always better to have a reduced steel percentage to have an economical column. In that case, 1 to 2% reinforcement, 1 to 2% is generally economical. But I said cross-sectional area will be the load carrying capacity if it is 2.6% reinforcement. But when 2% reinforcement is provided, just multiply the cross-section area with 0.9. So load carrying capacity 30 into 30 into 0.9, because we are reducing the reinforcement, load carrying capacity will be reduced, but by 10% only. So having this in mind, if you provide 2% reinforcement into 2.6, 2% you are providing, then 800, 30 into 30 will be 900 with 2%. So this is how it's a little tough for a structural engineer to assume the column size before doing the detailed analysis. Please, to suggest the architect the column size in the planning stage, it is little difficult for the structural engineers. But with this technique, you can overcome that difficulty. And for this 2% also I worked out something. So with this, I have covered some thumb rule EDC techniques for slab, which many of us know, and thumb rule for beam, most of us know, and column thumb rules, which only few of us know. I remember a story. There was a primary school teacher who was handling a geography class. She was teaching about mother planet. She was telling our mother planet is the great one. It is in solar system and it has so many mountains, rivers, and it consists of 7 continents and all. And before closing the class, a student boy stood up and asked the miss, "Madam, I am very happy to see our mother planet is made up of so many rivers, mountains, continents and all. But what is the weight of a globe? What is the weight of mother Earth planet, madam?" she asked. But madam didn't know the answer at that time, because no one can be a master of everything. But she didn't want to reveal in front of these kids. She is unaware of it. She told them, "It's a very good question, but it has come at the end. I leave it to you as an assignment. And you do the assignment and come and submit it tomorrow." And as this class is over, the students went home and madam went to the library or referring some encyclopedia or something. She was able to find out the weight of mother planet is 6,000 trillion tons. She biotted it, 6,000 trillion tons, 6,000 trillion tons. And after coming to the next class, as soon as the student assembled, she asked, "How many of you have done the assignments?" As usual, none has done. As usual, she scolded them for some time and told, "Yesterday itself, I know the answer for the weight of the globe, but I wanted to check the capability of the students to do the assignment, surprise assignment in time, but no one is capable. So now I will reveal the answer. The weight of mother planet is 6,000 trillion tons. And with that answer, she looked at that boy who asked the question yesterday with a pride face. That boy said, "Thank you, madam," but should, and asked again, "Miss, whether it is with people or without people?" By this time, the miss fell down on the floor and became unconscious. Similarly, if you ask a civil engineer, structural engineer, the size of beam, size of column, assessing the size of beams and slabs, to be able to give a position. If you ask them to assess the columns, it is a little difficult. We have to fell on the floor, then we can tell. So it's a little that magic. So everyone will have their own customized thumb rules. So you make use of this and get benefited. So sizes of footings, and also when we say isolated footing or something, when an earthwork is going on, our neighbor will call upon us when we go to the office outside. No, being knowing civil engineer, you will ask whether the excavated footing, the masonry, that mason says this size is enough. You just verify whether the excavated size is enough or not. We cut a sorry figure. Yeah, immediately we won't be able to tell. We need a lot of bookwork to do all those things. To overcome this, you see, is the one. Similarly, we have worked out, similar to columns, we work out the load on columns. Of course, we load on the column, we have 800 kN in hand. But one more parameter which plays a major role in deciding upon the footing size is SBC, safe bearing capacities. Like COVID-19, nobody has identified a method so far to assess the correct SBC of the soil. No watchers agree. No soil consultant will agree with each other. One will say SBC is 200, other will say 250, one will say 150. So it's very tough to find out exactly determine the SBC of the soil. But still, if I say the following thumb rules, or hard soil or soft rock, SBC of the clay is assumed as 100 and coarse sand as 150 kilonewton per meter square, or 10, 10 or 15, 10, 25 SDR. It goes like this. You just buy at it. But if there is any geotechnical consultant and any soil mechanic, they will scold me. A lot of things are there. But still, for estimate purpose or for a small buildings, just by observing the trial pits or excavated earth, you can assume it will work out well. So knowing this and knowing the load on column, just you can find out the area of the footing like this. So normally 800 kN the load, 80 ton, and 10% we have for the self weight of the footing. And say clay means immediately it will strike to my mind 100 kN per meter square, the SBC. Then the pressure due to this should be less than 100. When it will be less than 100, you provide 3 meter by 3 meter. So 880 or approximately 900. If you divide this by 3 into 3, you will have 98, will be less than 100. So reverse, you can work out the load by SBC will give area of the footing. You can find out the size of the footing. Load by SBC will give area of the footing. If I say like this, we have thumb rules for size of the footings also, which very rare to find out. This is also a rare piece for various SBCs, and knowing the size by these are the coefficients 7, 5.5, 5, 4.5, 4, 3.5 are for various SBC of the soil. You can divide by this coefficient in order to get the size of the footing. If it is a block footing which we adopt nowadays, if it is a 100, just size of the footing 3 meter, you divide by 5.5. Coarse sand, if it is 150, you divide the size by 5. With a 3 meter, 3 by 5 will give 600 as the footing thickness, something like this. So you can, somehow you can work out, and a lot of tables also you can develop like this for grade beams, for staircases. You can develop your own staircase or your own tables and get, you develop, my advice is not to agree with me, you develop your own ready reckoners or thumb rules with you, and you verify or exercise it in your projects, and you will find out, you will get a confidence, you try to use it. But I have covered the first part, thumb rules, but you must handle those thumb rules with care. You must handle those thumb rules with care, because I made a lot of assumptions. It cannot be said equivalent product for a detailed structural design. But for an emergency or preliminary design, you can make use of these techniques. Even for it will be more applicable for moderate span buildings. And I assumed full wall all round. I assumed this for these coefficients. I assumed full wall all round, which is the usual case in buildings, and partition walls of brick wall inside the buildings. That is my assumption. But for staircase portions, toilet portion, for the columns and beams, you have to make some additional loads based on some common sense and that. So many are raising their hands. I'm scared. The spans of this beams assumed are small or moderate, up to 6 meters. These thumb rules will work out well, because this moderate span will not create significant moments in columns. But if significant moments are expected, rational additional loads may be considered based on some consideration with others are doing the detailed analysis. So this is applicable for moderate span with usual profile of the buildings. Hence, I request all the participants to use these techniques with common sense and civil engineering. So I won't take more than 5 minutes. We have covered these thumb rules now. But structural failure, one case study we will see. If a building failed, this was like this in 2014 in Chennai. There were twin towers like this. There were twin planning. This is original. It's only architectural elevation, isometric view. Two buildings were planned, G+11, 12-story building, and both are similar. A and B, tower 1 and tower 2, both are similar. Tower 1 has fallen, and while taking these photographs now, this was waiting to fall. Skills plus 11 or 12 floors. Now, if you observe this now, we have left wing, and right wing, connected by alternate floor ties. This staircase height. So during failure, no, it has split vertically into two halves. Pancake failure. One left portion has fallen left, and the right portion has fallen right. So even you can count this like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 11. 1, 2, 3, 4 like this. Vertical split was there. When we were furnished the drawings available at the site, no, we were given this plan only. You can see it has 1, 2, 3, 4 columns like this, 4 columns like this. Similarly, that right wing is the left wing, connected by weak staircase portions. So left wing and right wing connected. You can see 1, 2, 3, 4 columns here. 1, 2, 3, 4, 5, 6 columns. The span is approximately 3.7 here. 3.7, 3.7, 3.7. Here again it is 3.7 or 4 meters something. But here you can see 8 meter span. 8 meter. There is no column here. 8 meter. Then again approximately 3.7, approximately 3.7 meters. Or 4 meters, I can say 4 meter, 4 meter, then 8 meter, then 4 meter, 4 meter. Then this is 4 meter, 4 meter, 4 meter like this. You see in the plan what we got, we had like this 1, 2, 3, 4 columns. So you see these walls, just kindly be key enough to notice this failed building. How it failed, you will understand. This beam, this wall is there, this wall is there, this wall is there. Only if the column is here, if you provide beam like this and provide wall over here, only if there is a column here, and if you provide wall like this, you have to support a beam like this. From the beam it has to go to the columns. This is the column. Like this is the method we know. So this is the short span. But what that fellow has done, he has removed this column entirely. See, this beam to support the wall, this beam to support the wall. He is not able to transfer the load the column here because that one of the developer or somebody has come and told is the driveway. It's very difficult to turn the car, inconvenient to turn the car like this. So remove the column. Don't provide the column here. It is not necessary to provide the column here, and they have not provided the columns here. As a result, all the loads will be transmitted like this to this beam. Previously, this would have been the very short beam with the column here, But now it became ulta, and this became the supporting load beam. All the loads to be carried by the long beam, 20 meter long, and it has to transfer the load to this main beam like this. But what they have provided as a beam depth for 20 meter, as per our thumb rule, for 6 meter, we will just multiply by 7.5 and say 45. If it's an 8 meter, we will say by 7.5, 60. If it's a 20 meter, you can multiply by 7.5 the coefficient for beam depth. 20 into 7.5 will give 1.5 meter depth. Of course, our height, such a huge building beam should have been provided in this building. We need 300 by 1.5 or 400 by 1.5 is the beam depth required because of this wrong load transfer by removing these columns here. But what they have provided is only 450 mm depth. Instead of 1500 mm, they have provided only 450 mm depth, and the structural deficiency was there. And also, coming to the load on column, they have removed this column here, and also the span is very high, very long here on one side and small here. So I worked out the load on column, and just seeing the diagram, you yourself can work out. A little consideration will show you this tributary. This is the tributary or influencing area of this column. What I am marking in the mouse node, this one. So if you work out this plus this and this 3.65 and something, it comes about 22 meters square. 22 meters square. It is an edge column. You assume 22, not 22. You keep it in your mind as 20 meters square. 20 meters square is the influencing area of this column. And for edge column, our coefficient will be for interior, if it is a resident building, 12, interior will be 12, and the edge column it will be 17. So 17 is the coefficient to be multiplied with the area 20. Instead of 17, you assume in your mind as 15. So 20 meters square into 15 is the coefficient. 20 into 15 will give 300 kilonewton. 300 kilonewton on the load, on the load on the column. 300 kilonewton for single story. For 12 stories, it will be 300 into 12, 3,600. So for 12 stories, load on column is 3,600. So our thumb rule, load on column is nothing but cross-sectional area of the column. So for 900, I have provided 30 by 30 centimeter. 900 load on column, I have provided 30 by 30 centimeter. For 3,600, it would have been 600 by 600 or 60 centimeter by 60 centimeter, which is a square column. If you restrict one side as 30 instead of 60 into 60, it will become 30 into 120. 300 into 1,200. That much size is needed for even an ordinary vertical load. 300 by 1,200. You can just learn it from our thumb rules, which we have discussed. But what those fellows have provided is only 300 by 450. 300 by 450. Whether column or beam, they never want to change from 300 by 450, irrespective of the span, irrespective of the stories. So everywhere, ₹1 எதிர்த்தாலும் வாங்குற மாதிரி எது எடுத்தாலும் 300 by 450. They provided only 300 by 450. And this is the mere pure structural failure because of the structural ignorance and site ignorance and many other faults. Any building will not merely fail because of one reason. There will be multiple reasons. One of the significant reason is the design. So this, you can see this figure now, this column, they have not provided here. This, which suppose if they would have provided na, would have been safe. And also they failed in foundation also, they provided only wrapped foundation. Here we have to go pile for about 20 meter. Soil geotechnical report says we have to go for 20-meter pile for building this 11-story building because of poor SPC of the soil. Hard strata is available at 20 meters. They have not provided that also. If that building has not failed during construction because of structural, that would have failed by foundation failure after the people have occupied. So it would have on the other way also. And I'm nearly at the end. One more, this collapse of roof of a bus stand in Coimbatore last year. Here also it shows the ignorance of the people. This is a cantilever slab, just a small structure only. But they have loaded like this. They have added additional parapet wall. They have added on 2000 liter capacity on this cantilever slab. Cantilever slab themselves are very vulnerable. They have not provided rod like this. They didn't made as simply supporter continuous. They provided like this sunshade type rod, and it behaved like a cantilever slab. And on the cantilever slab, they have provided overhead tank and parapet, and they failed to put drain hole also. When rain comes, no, it cannot escape. It will be simply the entire bus stand roof area will act as a huge reservoir. So on the other day when it was failed, no, in Coimbatore there was a continuous rainfall for 4 days. So all water stagnated there and it made ultimate collapse. What I would like to say, the common sense must be used before loading a building, rather than while designing. While usage also, engineer must know the behavior of the structure. If not, go on loading that. So many times, though we do lot of hard work using analysis data, STAT3, STAT Pro, ETAPS, many analysis done, and with the need structural drawings and all, we send to the site. There is no supervision. You can see these types. See, a column instead of here, it went a little bit away. See, the columns are here, and simply for utility purpose, they have shifted the column unnecessarily here. See, that fellow is making that wiring, no wire pipe. He has simply broken not only the stirrups, lateral ties, he has broken the main rod also. He has broken the main longitudinal bars also. And after plastering, no, everybody will see this. See, he has broken the entire beam itself. There is nobody understands the load transfer. Whenever we put some drawings, now we put some cloud. By mistake, if it goes to site, this may happen. See the staircase. No one can climb to the first story without a rope. See, this is the waist. Landing now. Only thin persons can go out, and only kids can go up and go down, come down. See, architect wanted to place staircase here only, but our structural engineers adamant to place the column on the staircase portion only. Non-integration of structural engineer and architect. See, only the road goers, no, they can use this balcony. If this fellow opens the door now, the non-integration of our government departments. No comments. This is also like that. This happens many times. Many will say this is not my job. This is not my job. Project manager asks, why didn't you have the rat removed before painting? Site engineer says, no sir, it was not mentioned in the technical specification. This is how it happens in the site. See, a small little thinking could have avoided this. Once you open this, you cannot open this. See, a very little thinking has made the purpose waste. See, who can use the 2 toilets at a time? No, one can use the toilet, but lack of common sense. Again, opposite also, as if they are traveling in a train and talking, no seat. Placing a water closet in a wash basin area is ridiculous. See, only one can use. Only twin brothers attached to the head and hand and can use it. Special lack of common sense. With the idea of not wasting water, and this has come. Who can use this urinal and who can use this wash basins? See, a little non-application of mine made him to make a European water closet as Indian water closet. See, this is some urinals. They have put transparent glass. Road guys can observe this. No? A little thinking, opaque glass to be provided. So this is the climax. Just in spite of putting this doors at the bottom, no, without knowing the purpose, he has put at the top. So this is what is happening in the field without our knowledge. We are 300 mm, 230 mm and all we are discussing. What's happening in the field is like this, is to be streamlined with a good supervision. And last slide, I'm a popular successful structural engineer because of this. So no comments. And avoid blunders. This is the last slide, really last slide. Avoid blunders due to hurry in works. Whenever we are hurry, no, somebody will pressurize to do that and all, no, the final A will be spoiled. The final, not only nowadays, in olden days also, in hurry, they have done many mistakes. One among this is, you see the Gandhi statue, Mahatma Gandhiji, in Marina Beach, is walking like this. You see his stick, walking stick, is put in front of the right leg, holding stick in the right hand, like this. I have shown the enlarged view like this here. See, in front of the right leg. This is not possible. A normal man who walks will be like this. A stick will come parallel to the left leg, then stick will come adjacent to the right leg. This is the way, style in which he walks. If he walks like this, now he will fall down. The stability will be lost. They have made such a beautiful statue. It's in 70s they made. 70s they made. Final checking, no, final checking is required, though we do a detailed, refined analysis. So this is my final submission. So with this, I would like to thank, I will close my session, and I would like to thank all the participants and also delegates for patient hearing and encouraging me. Really, once again, I want to emphasize that it's really a honor to me to spend this wonderful Sunday with you, sir. Thank you very much. Thank you to all.
जन गण मंगल गायक जय हे भारत भाग्य विधाता जय हे जय